We've all seen this kind of right triangle problem where you know two sides, in this case 12 and 18, you need to know the third, and immediately the Pythagorean theorem comes to mind, and you know that a squared plus b squared equals c squared. So of course you write out 12 squared plus 18 squared equals x squared, and from there you can solve the problem. Well, in this video, we're going to look at things from a different perspective. What if you don't know two sides? What if in case you know an angle and a side and you want to know a second side? What would you do to find that side? That's what we're going to be looking at. Stick around. Here we go. In order to solve this problem, you're going to have to learn something called trig ratios. Trig ratios only work when you have a right triangle. So over here where you see this right triangle drawn, you'll see the right angle symbol. You're also going to have given some sort of angle. And for some reason in math, somebody at some point decided, you know what, that angle, let's call it theta. It's a Greek letter, and that's what it looks like. It's kind of like a zero, a little squiggly through it there. And then across from that is going to be what we call the opposite leg. And that's because it's across or opposite from the angle itself. And it's a leg because it's one of the two sides that makes up the right triangle. The adjacent leg is next to the angle, so you'll see that theta and the adjacent leg are next to each other. And then, of course, we have the hypotenuse over here, which is across from the right angle itself. And so there are some ratios. One of them is called sine, one of them is called cosine, and one of them is called tangent. And these are the abbreviations. These abbreviations are what you're going to see on your calculator. There'll be a sine button, a cosine button, and a tan button. And they're defined as if you take the opposite leg and divide by the hypotenuse, that's what sine is. The cosine ratio is the adjacent leg divided by the hypotenuse. And finally, tangent is known as the opposite leg divided by the adjacent leg. The reason why I highlighted the first letters here in each of these fractions is for this. There's a mnemonic that people like to use to remember what goes with what. And so if you look at the first three letters here, you have SOH. The first three letters are CAH. And the first three letters over here that are highlighted are TOA. So we have TOA. So that's a way that a lot of people use to remember which ones go with which. So the S stands for sine, and the O is opposite leg, and then H is hypotenuse, etc., etc. What we're going to do right now is we're going to go and take a look here and look at this right triangle here and actually solve the problem. So I have my angle over here, my theta, and if I look directly across from that angle, that would be my opposite side. So I'm going to put an O over there. My hypotenuse is always across from my right angle, so I'm going to put an H over here, and that leaves the adjacent leg, which is right here. And you'll notice that 30 is right next to 37, and that's what adjacent means. So in this case here, we have an angle, and we have we want to know the opposite leg, and we know the adjacent leg. So this involves opposite leg and adjacent leg. So of these three over here, the one that involves opposite leg and adjacent leg would be tangent. So what we're going to do is we're going to write tangent of 37 degrees equals x over 30. From here, to solve this, we're going to make this a fraction by putting it over 1. And what we can now do is we can cross multiply. So in other words, 1 times x, which is just x, should equal these two diagonally multiplied by each other. So I'm going to say 30 times tan 37 degrees. So what you want to do right now is you want to go ahead and grab your calculator and you want to enter in 30 times, find the button that says tan, and immediately when you do that, you'll see that there's a left parentheses added in right here, and that's fine. And then just type in 37. There's no need for a degree symbol, so it'll just be 30 times tan 37. Go ahead and press enter, and if you do it correctly, the decimal answer would be approximately 22.61. We're not going to worry about units for all this. We're just going to go ahead and just say what the measurement is. We'll worry about units at another time here. So that's how you do this particular problem, and we use tangent once again because it's opposite and adjacent. As always, if you like what you see, please like, comment, or subscribe. Thank you, and back to part 2. Let's look at a couple more problems here and see how it might work in other situations. So once again, we have a right triangle here. Our angle is 63. What we're going to do again is we're going to say, well, what's directly across from that angle? So if we go directly across, that would be our opposite leg. The hypotenuse is directly across from the right angle, so that's going to be where we put our H. And down here would be the adjacent leg. So we want to know the opposite leg, and we know the hypotenuse. So we have to figure out which one of the three ratios we're going to use. So this involves O and H. So that means when we do this here, we're going to be focusing on SOH because OH is our opposite leg and hypotenuse. So we're going to be using sine here. So we're going to say sine of 63 degrees equals, opposite would be x, so we're going to say x, and then hypotenuse is 15. As always, we go ahead and put it over 1. Now we're going to go ahead and we're going to cross multiply at this point. So 1 times x is x. And when we cross multiply this direction here, we get 15 times sine 63 degrees. So grab your calculator, multiply 15, and then say times. Hit the sign button, then hit 63. As always, you do not need a degree symbol. There isn't any on the calculator. So it's just 15 times sine 63, and if you did it correctly, x should be approximately 13.37. So that would be sine in this case here because we're using opposite hypotenuse. So here's another one. In this case here, our angle's up in this corner and the triangle's been rotated a little bit. So if I go directly across from it, that's my opposite leg. Across from my right angle would be the hypotenuse. And then next to or adjacent to 32 degrees would be the adjacent leg. In this case, we're looking at adjacent hypotenuse. So we're going to be looking at the part, so CAH. So that'll be cosine. So we're going to go ahead and write out cosine 32 degrees equals, we're going to put the adjacent on top, so that would be 44. And then the bottom is going to be x. I'm going to go ahead and make this a fraction, so over 1. At this point, we're going to cross multiply. X times cosine 32. Well, x times cosine 32, we don't really know what cosine 32 degrees is, but I'm sure it's something. And then if we go this way, it's going to be 44. So this one is a slightly different. You'll notice here on the first problem, x is on top or x is on the bottom here. So the calculation is going to be slightly different here. So and what we have going on here, since we have x times cosine 32, cosine 32 is just a number. So if that had been x times 2, we would just divide both sides by 2. So then what we're going to do in this case is we're going to just divide both sides by cosine 32 degrees. When that happens, those cross off. Over here, we're going to get 44 divided by cosine 32 degrees. So on your calculator right now, go ahead and do 44, hit the divide symbol, and then type in cosine 32. And if you did that correctly, you should get x is approximately 51.88. So that's the basics of how to use trig ratios, where you know an angle, you know a side, and you want to know another side.